Assalamu alaikum, Doctor. We're Group 5, Phase 3, Implementation and Testing. We have connected almost all the sensor and gear driver and driver module. But before we connect everything to the microcontroller, we're still in the testing phase. We need to make sure that each component is working perfectly on its own before we connect everything to microcontroller. So first we need to check the gear motor. So for the gear motor, we need to understand how the driver module work. We connect both power for both motor to pin 0 and both motor on the left side for pin 2, and the other two for pin 1, and the other two is for pin 3 on the side. So we have these three. This is to get power from the battery and the ground. Then this pin decide which direction we are going to by sending signal to each of these pins. So when we connect all of these to the microcontroller through code, and depending on the situation, we can decide on which direction should the driver module gear go to. So the first pin is for the left motor, moving backward. The second pin is for the left motor, moving forward. The third pin is for the right module. The fourth pin is also for the module, but moving forward. Right, we need to make sure that the connection is secure. Okay. Yes. So now we just need to test the ultrasonic sensor and test the IR sensor for the line tracking and for the optical avoidance. And now we need to check the servo and the ultrasonic sensor. So we have connected first our motor, these 4 pins. We've connected them to the shield, and then these are the 4 pins. In 0, in 2, in 1, and in 3, the same naming on the driver module. So now using this code, we can signal to move forward or backward, of course depending on the situation. So for the distance, we've set the distance is equal to the read ping. The read ping is for the ultrasonic sensor. So it's going to check the distance, and depending on the distance, it will send signal to the right motor, left motor. This is distance right, distance left is for the servo motor. Okay, something important, the most important part of the code is the read ping. This is for the ultrasonic sensor. We need to set to a max distance, so for the signal to go in and out, and of course divide by 2 to get the distance. This is important because for the servo motor, you need to turn right, you need to look right and look left. You call this function, and this function look right and look left, they move the servo motor left and right, and it will check whether there is an object in front, which side to better go. So should I go left or right? So like in an intersection, if there is like a car in front and it's stopped, let's say, it will go check left and right. If there is car left, there is like short distance compared if you look the other side, there will be like longer distance, so it will go to the other direction. So now we have installed the code. We just need to plug the battery. So now the car is moving forward at the default stage. So as soon as the ultrasonic system detects an object, it's going to stop. then the servo motor will look left and right to look which direction should it go through. So now by putting our hand, we can make sure that the ultrasonic sensor is working, and through the servo motor we can, by looking left and right, we can make sure that's working. So better improvement we can make for the ultrasonic sensor is to add the code to display the distance on the serial monitor. What I have left is the infrared sensor circuit and the 4 IR sensors. Before testing, we disconnected the motor, so the car doesn't go. And this time, we don't really need to use the serial monitor or the code, because the infrared circuit have 4 LED indicators for each IR sensor. So we can test it by covering the light from detecting the IR sensor, and for, of course, the position. This is the left sensor. It will light D4. This is the middle left. It will light D2, and this is the middle right. It will detect D2, and this is the right to detect D1. So we know our positioning is correct. And if we remove the light, of course, in line tracking system, we will not cover it. We will put a black line, so it will detect the density of the light. So, for example, if we have a black object right here, we need, of course, to increase the potentiometer. We have for each one 4 potentiometer. We change it depending on the track, and we increase it or decrease it depending on object. Of course, if we cover it, because we have the lowest density, it will light. So of course, we just need to tinker with this potentiometer depending, of course, on our road and condition. And of course, for the code part, we added for the IR left center, and IR right and IR right center. We have declared each pin, and of course we need to set the motor to output and set the IR sensor to input. So it's going to read the input. If it detects a black line, so there is a reduction in light, it's going to send the signal depending on the code, this code, if low or if light, else if. So what this code exactly do? If these two sensor detecting a black line, of course we will put them together at the center. If they detect a black line, that means they're in the center, and if the other two are not detecting a black line, that means it's going on the right track. The motor will go forward. If the black line shifted, it will slightly it will slightly tell the left motor to move backward, so it will move like this. And if it only this sensor detects the black line, it will move way more to the left. Of course, if the black line shifted to the other two sensors, so these two, it's going to tell the right motor to go backward, so it's going to move to the other side. This is exactly what does this code do.